we're on about episode 10. We're coming to our last few lessons, and we're going to be finishing out chapter 3. This lesson, we're going to get into what we call the proportion. The proportion basically is setting ratios equal to each other. Our strategy is going to be cross-multiplying. That's going to be our little strategy. The way this plays out is, again, when you have like 3/4 equal to 6/8, like before we had like 3 parts sugar to 4 parts water, I could kind of make the recipe change into 6 parts sugar and 8 parts water, and I shouldn't have changed the flavor any. Because it looks like, essentially all I've done is double the recipe. If you double the recipe, the flavor hasn't changed, just the amount that you have has changed. So that's kind of a little bit about what a ratio is doing. And what's true with ratios, if these are actually true, what has to be true is the cross products have to be true. So 3/4 equals 6/8 because 3 times 8 has to equal 4 times 6. And we do see that 3 times 8 is 24 and 4 times 6 is 24. So anytime we have a true proportion, for it to hold true, this cross product has to also be true. If that cross product fails, then it's not a real proportion, it's not a true statement. So that has to hold true, otherwise we do not have a proportion. And this does hold true. So again, when you have a fraction equal to a fraction, or what we say setting ratios equal to each other, we call that a proportion. So again, this is an example of what a proportion is going to look like. So it's going to take on the look of an equation. So let's put it to some use here. Let's determine the value of x in these examples. So if I want to find the value of x, what I'm trying to do is figure out what makes this true. So what over 5 is going to equal 4 over 10? Well, you may have some instincts. If this is doubled, then this has got to be doubled. Okay? But what would that have to be? Sometimes I get spun around, and sometimes what I like to do is just go ahead and I think more clearly if I use the cross product. So again, I usually do the diagonal that has the variable in it, so I like the variable on the left side. So 10 times x, or 10x, has to equal 5 times 4, which is 20. Now this looks a little bit more meaningful to me. I've done some of these earlier, and I think actually in chapter 1 that we did some equations that look like this. So 10 times what number is 20? Well, if this is 20, I know this has got to be 20, and again, what number would x have to be to make that true? And we would see that x would have to equal to 2. 10 times 2 is 20. Or remember, since this is multiplication, you could go backwards and divide. And that would also tell you that the answer is 2. But if you can see this, that's 10 times 2 is 20, you're done. Let's look at example 2. Again, we're trying to figure out what's the value of x here. And also again, x can be anywhere. It doesn't have to be in this upper left hand. X is over here now. So again, I'm trying to figure out what makes this true. And again, you may say, well, that looks like that's been tripled. If this has been tripled, then this has got to be tripled. So you may be able to see the answer that way. If you can't see that, anytime we have proportion math, we are allowed to kind of what we call cross multiply. So I like to do the variable first. So it's 12 times x equals 5 times 36. Well, that's a little bit more complicated. 36 times 5. Looks like we're getting 180. So now I'm trying to figure out 12 times what is 180? Well, I'm not seeing that, so again I can use division to figure that out. So x is going to equal then 12 going into 180. So my oldest go away, 12 goes to 18 one time, 12 comes down, 6 comes down, 12 goes to 60 5 times, 5 times 12 is 60, my remainder is 0, so that tells me the answer is 15. So 12 times 15 would give me that solution. So I got a little work to do on that one. But if you saw that this is tripled here, 5 times 3 would be 15. You can use a shortcut there too. Otherwise, proportion is a good strategy. So again, trying to find the value of x. Again, we have a fraction equal to fraction. We're allowed to cross multiply. So this product and this product has to hold true. So 20 times x has to equal 9 times 7, which is 63. 20 times y is 63. I'm not really feeling that at all. So since that's multiplication, I can go backwards and use division to figure that out. So x is going to equal 63 divided by 20. If we'll go ahead and divide that out, again, I can use some long division. 20 into 63. Looks like 20 goes to 63 about 3 times. That's going to be 60. I get a remainder of 3. If I want to do decimals, I can put a decimal there and add a 0. 20 goes to 30 one time. 20 comes down. 1 times 20 is 20. My remainder is 10. I can't stop there. Add another 0. Slide that down into the problem. 20 does go in 100. Looks like 5 times. 5 times 20 is 100. So it does play out as remainder 0. So that's why that was so crazy, is the answer was not a whole number. The answer was actually a decimal number. So the answer would actually turn into 3.15 if I was using decimal notation. Okay? So proportion math is very powerful because we create an equation, and the equation can be solved by cross-multiplying first. Then it makes it look like something that we can manage back from chapter 1. Okay? So we'll see if we can put that to use. Stay tuned.